Google has just pushed out one of the most important AI upgrades of the year, and the entire industry is paying attention. DeepMind introduced SIMA 2, an advanced goal-driven agent that understands 3D environments, plans its actions, and even teaches itself new skills. At the same time, another mysterious model inside Google AI Studio started showing almost perfect handwritten text recognition and surprisingly strong symbolic reasoning. And while this was happening, new leaks of Nano Banana 2 appeared online, showing visual abilities that look similar to Google's internal Gemini image engines. All these breakthroughs arrived around the same time, and together they show one clear direction. Google is building systems that act less like tools and more like world-aware intelligent agents. Let's break down what SIMA 2 actually is and why people are calling it the next big step toward embodied intelligence. Last year, DeepMind introduced the first version of SIMA, a generalist agent trained to handle basic commands in different virtual games. It could turn left or right, climb ladders, open maps, walk around simple levels, and react to user instructions. The model followed more than 600 different actions across multiple game engines, which was already impressive at the time. But it struggled with long tasks that needed planning. When DeepMind compared its performance with real human players, SIMA managed around 31% on long multi-step challenges, while humans scored around 71%. In short, the agent could follow steps but could not hold the bigger goal in its memory. SIMA 2 changes that completely DeepMind replaced the older internal reasoning system with Gemini as the main thinking engine. This gives SIMA 2 a deeper understanding of goals instead of just reacting to instructions. Now the agent can explain why it is doing something, break down tasks into steps, and check if its actions match the goal. It is starting to behave less like a scripted bot and more like an intelligent player that plans ahead. To train SIMA 2, DeepMind used a combination of human demonstrations and automatically generated labels from Gemini. Humans provided example gameplay videos with text descriptions. Then Gemini filled in missing explanations to create a much larger and more detailed dataset. With this combination, the new SIMA model nearly doubled its performance on long horizon tasks and stayed robust across different game engines. The most interesting part is the generalization. SIMA 2 can enter new virtual worlds it was never trained on and still perform well. For example, DeepMind tested it in Asuka, a Viking-themed survival game, and in Mind Dojo, which is related to Minecraft. The agent handled complex tasks involving mining, crafting, navigation, and exploration. It even understood sketches, emojis, multilingual instructions, and multi-step prompts. If it learns a skill in one game, it can apply the same logic in another game without needing new training. DeepMind calls this transfer learning inside 3D environments, and it is something only a few AI systems have ever managed to do reliably. In one test, SIMA 2 entered No Man's Sky, a massive and unpredictable open-world game, and acted as if it had experience with the environment. It mapped the terrain, located a distress beacon, and built a sequence of actions to reach the objective. This level of planning suggests that the model is forming a deeper conceptual understanding of worlds rather than memorizing actions. Things get even more interesting when SIMA 2 is paired with DeepMind's new world generator called Genie 3. Genie is a real-time generator that can take a drawing, photo, or a line of text and instantly turn it into a playable environment. The world can contain random objects like trees, rocks, benches, animals, enemies, or tools. SIMA 2 can jump into these generated spaces and operate inside them as if they were professionally designed game levels. It walks around, uses items, interacts with objects, and completes missions even when the generated environment has noisy textures or chaotic layouts. Because these worlds are synthetic, the agent does not depend on expensive human-labeled data. It learns through a cycle where one Gemini model creates a challenge, another model evaluates the results, and SIMA 2 repeats the task until it improves. This loop lets it gain new skills in environments no human has ever labeled. DeepMind says this is the early foundation of agents that learn general physical reasoning before interacting with the real world. The long-term goal is robotics. DeepMind openly talks about SIMA 2 as a high-level system that eventually controls robots. In this setup, SIMA 2 decides what needs to be done, while a lower control layer manages the physical movement. Similar to how NVIDIA's Isaac robotic system works or Meta's habitat simulations operate. Real-world environments still challenge robots with clutter, shadows, uneven surfaces, and unpredictable objects. But an agent like SIMA 2 closes part of the gap because it understands the scene, the objects, and the logic behind actions before attempting physical movement. Once the meaning is clear, the remaining problem becomes mechanical control, which is an engineering task rather than a reasoning task. While SIMA 2 was gaining attention, something else surprising happened. A historian named Mark Humphrey was using Google AI Studio when he noticed a new unidentified model during an A/B test. AI Studio sometimes gives users two model outputs and asks them to choose which one is better. Many people believe Google is silently testing early versions of Gemini 3 in this way. Humphrey uploaded handwritten materials from the 18th century, documents that are usually extremely hard for AI to read. These pages had messy grammar, inconsistent spelling, old currency symbols, ink smudges, and irregular handwriting. Most AI models perform poorly on such documents, but the mysterious Google model delivered near expert-level transcription and interpretation. For reference, Gemini 2.5 Pro already had strong accuracy, around a 4% character error rate and roughly 11% word error rate on tough manuscripts. The new model brought the character error rate down to about 0.56%, and the word error rate to about 1.22%. That is fewer than one mistake every 200 characters. The most surprising part was the reasoning. When decoding a merchant's journal from 1758, the model not only transcribed the text, but also interpreted the meaning behind the currency notations. It correctly understood that the price listed as "to 1 loaf sugar 145 at 1/4 191" referred to £1 4 pence as the price, and that the total cost had been written with shorthand. The model converted shillings and pence into numeric values, checked if the total amount matched historical currency rules, and concluded that the correct interpretation was £1 and 4 ounces. It even added the LB and OZ labels on its own. This is not simple pattern recognition. It is multi-step reasoning involving unit conversion, ambiguous symbols, and historical context. Many researchers call this emergent implicit reasoning, a stage where the internal representation of the model becomes so rich that reasoning emerges naturally. Other users online reported similar results on chemical notation, ancient accounting shorthand, and unclear dates in manuscripts. If this ability is real and stable, it can change the way old archives, books, and historical works are processed. AI would no longer collapse when facing old spelling or vague handwriting. However, historians warn that such systems must remain transparent. When AI starts correcting historical texts, its interpretation could influence the final understanding of those documents. Humphrey said the model should work with experts, not replace them, because even the best reasoning models can still embed biases. And all of this was happening while another part of Google's ecosystem started leaking. A new version of Nano Banana, known as Nano Banana 2, briefly appeared on media.ai before the listing was removed. During the short time it was visible, users downloaded several sample images. More examples appeared later on social media from creators like Mars. Everything Tech and LEO Nano Banana 2 appears to produce sharper, more consistent images with high detail and excellent text rendering. It can write long sentences on whiteboards with proper spacing and clean letter shapes, something image models normally struggle with. The model also shows strong photo restoration. Low resolution or blurry images are remastered into clearer visuals with more accurate colors and sharper lines. Some people believe its output is very close to Google's internal Gemini image engines that are not yet public. The new model also follows complex prompts more accurately. Instructions that mix spatial layout, object details, and world knowledge are handled cleanly. This is important for creative workflows because a huge amount of design work depends on generating high-quality assets quickly. If Nano Banana 2 becomes available through an API, many content creators, design teams, and social media managers will gain a major productivity boost. Google has not given any official release date, but the leaks appear more frequently now. Combined with the other updates across Google's ecosystem, it seems like a larger rollout is coming soon. When you look at everything together, SIMA 2, the silent model inside AI Studio, and Nano Banana 2, you can see a clear pattern. Google is pushing toward AI systems that understand the world instead of simply predicting the next token. SIMA 2 shows world-level reasoning inside 3D environments. The new studio model shows deep symbolic reasoning across messy historical documents, and Nano Banana 2 shows visual intelligence that follows complex instructions with precision. If these systems continue improving at this pace, Google may end up shaping the next major phase of AI, one where agents understand goals, interpret information, and interact with the world in a more human-like way. Thanks for watching. Drop your thoughts in the comments and stay tuned for more updates on the future of AI.